Hey guys, welcome back. We're going to do the last third of this chapter 9 review today. So it's going to be numbers 18 through 25. Alright, let's take a look at number 18 here. It says to solve by using the quadratic formula. So if you recall, we can't use the quadratic formula until that is in standard form. Okay, so to get that in standard form, we need to move the negative 4x to the other side. So our new equation should be 3x squared. And if I'm going to move that negative 4x to the other side, I've got to add 4x to both sides. Minus 1 equals 0. Okay, and then, well, let's just plug it into our equation. Negative b plus or minus the square root of b squared minus 4 ac all over 2a. Okay, let's fill in some values here. Our b is going to be 4, so there's a 4 there and a 4 there. Our a is going to be a 3, 3 and a 3, and our c is negative 1. So we'll plug in a negative 1. So we get negative 4 plus or minus the square root of 4 squared is 16. Negative 4 times 3 times a negative 1 is going to be a positive 12 all over 6. 16 plus 12 is 28. Right? And so at this point, we're going to break down the square root of 28. Try to do the best you can with this, because we haven't spent a lot of time going over this. To be honest, I'm not sure if it's going to be on your test or not. But here's our situation. We've got the square root of 28. And I think I might have broken it down once or twice for you guys, something like this. But we haven't done it. You haven't gotten a lot of practice with it. So what are my factors of 28? Well, it's the square root of 4 and the square root of 7. Because the square root of 4 times the square root of 7 will give me the square root of 28. Right? So at this point, you're asking yourself, okay, I know what the square root of 4 is. The square root of 4 is actually 2. And the square root of 7, it's I can't find an answer to it. It's an irrational number, so you leave it as square root of 7. So your final value is going to be 2 square root of 7. So your answer here looks like that. Okay, and you see the 6 that's beneath it, right? Technically, that 6 could end up going to underneath both of those terms. Okay, so sometimes you see it written like that, or sometimes you see it like how we had it initially, like that. Okay, but just understand that when we're reducing 4 over 6, you know what, let me move that back. This helps us when we reduce. So negative 4 over 6 turns into negative 2/3 plus or minus, and I can actually reduce that. Okay, you're treating your radical 7 like a variable, right? You just leave it alone. Like if you had 26x, how would you simplify that? Well, you just worry about 26. Okay, so here you have 26 times the radical 7, which would be 1/3 times radical 7, which I don't really need to write that 1, right? So it's really rad 7 over 3, radical 7 over 3. And your answer is going to be A, okay? Because A is rewritten with that 3 in your denominator once. So if I wanted to rewrite it, I can rewrite it as negative 2 plus or minus the square root of 7 all over 3. So you can write that together because it's the same denominator. Okay, let's go to number 18, or excuse me, number 19. So what are the solutions to this equation? Again, it's not in standard form, so however you want to solve it, it's up to you. I would probably start with the quadratic formula, right? So I'm sorry that's cut off on the bottom line there, but if it equals 1, right? or excuse me, equals negative 1. Let me just rewrite that over here. So it equals negative 1. I have to move that to the other side. So I have x squared minus 4x plus 1 equals 0. Okay. Maybe at first glance, I want to see if I can factor this, because it'll be a quick problem to solve. What times itself equals negative 4 but adds to 1? Well, nothing, right? Or excuse me, what times itself equals 1 but adds to a negative 4? Nothing's gonna, it's just 1 times 1 equals 1. So it's not going to be factorable. So let's just jump straight into the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, let's just identify what we know. My b value is a negative 4, a value is at 1, and c value is also 1. So I get 4 plus or minus the square root of negative 4 squared is a positive 16, minus 4 times 1 times 1 is 4 all over 2. And again, 16 minus 4 is 12. So we've got our same dilemma here, right? What is the square root of 12? Well, we can break that down. The square root of 12, my factors are square root of what and square root of what? Well, 4 and 3. And we know the square root of 4 is actually 2, so our final answer is going to be 2 radical 3. So here we'll have 4 plus or minus 2 radical 3 all over 2. Okay, again, when I separate the denominator into two different terms underneath the 4 and the 2 radical 3, visually it's easy for me to reduce it. So I know 4 over 2 is 2 plus or minus, get rid of this down here, and then you notice that 2 over 2 will cancel, and that leaves me radical 3. And so our answer is D. It's 2 plus radical 3 and 2 minus radical 3. Alright, let's move to number 20. 20 says, which of the following has two real roots? Well, when it's talking about roots, it's talking about your x-intercepts, right? And it's talking about what x equals. And if it's asking you for two real ones, it's asking you ones that won't give you a square root of a negative number. Because when you get a square root of a negative number, if you recall, you're dealing with imaginary numbers, not real numbers. So, when you're solving with the quadratic formula, all this, excuse me, let me finish writing this real fast. Okay, so this is what we call your discriminant, and your discriminant will tell you how many roots you have, how many answers you have. And we talked about that before in class, but I know it's been a while. All right, so really, you just want to know what's in this green circle. If it's a positive, you know you're going to get two different answers. Because, let me show you, because you have a positive and a negative version of it, okay? So let me change the color here. You're going to have a positive and a negative version of this square root, whatever the square root is, right? If it equals 0, then you're going to have one answer, because you're going to add and subtract 0. It won't change your final answer. And if you have a negative number in this discriminant, you're going to have no real solutions, no real roots. Okay? So essentially you're just going to plug in one equation at a time and determine which one of these has two real roots. Okay? So, let me erase this and start plugging in some values. Alright, so if we look at A, our B value is going to be negative 12. And our A value is going to be 4. Our C value is negative 20. Really, I don't even care about all this right here. It doesn't even matter, right? But I'm just going to leave that there for now. So, the square root of negative 12 squared is a positive 144. And then I have negative 16 and times a negative 20. So that's going to be 32, 320, if that's right. Doesn't even matter because I know that's going to give me a positive result. And if it's a positive result, I'm going to have 2 real roots. Okay, so there's your answer. But let's choose another one that would disprove this. Okay, so let's see what happens if we plug in, if we use the equation in problem B. Problem B, my B value is negative 2, and my A value is 1, my C value is 15. Okay, and again, I don't even know why I'm writing my numbers down here, because it doesn't even matter what those are. So, negative 2 squared is 4, minus 4 times 1 times 15 is minus 60. I already know that that's going to give me a negative number, so therefore, that will not give me 2 real answers, 2 real roots. Okay? Alright, let's move to the next one, number 21. How many solutions does this have? So this goes back to the discriminant, right? Again, I just care about that b squared minus 4ac part, because that just tells me how many roots I'm going to have. I don't even need to solve it all the way, right? So let's plug in our b value is negative 1, a value is 3, c value is 5. Okay, negative 1 squared is positive 1, minus 4 times 3 times 5, that's going to be minus 60, and I have a square root of negative 59. That's going to give me no real solutions. Okay, I shouldn't cross that out, I should circle that. Alright, you're never going to get 3 anyways, so option D is never going to be a choice, not with quadratics. Alright, number 22 says, which of the following statements are true about this function? Select 2 that apply. Well, as you can tell, this function is in vertex form. And the vertex is going to be opposite of that, and you keep that, right? That's your h, your k. So vertex is going to be opposite of negative 4 is a positive 4, and then we keep the k value of negative 1. So we know that this is going to be, if I multiply this equation out, this is going to be x squared minus 8x plus 16 minus 1, right? And the reason why I'm doing this is because I'm looking at my leading coefficient, and if you notice it's positive, so I know it's going to be a positive, a happy face, a smiley face. The vertex is at 4, negative 1. So because my vertex is my lowest point, I'm dealing with minimums, right? So I don't have to worry about maximum anymore. Right? Do I have a 0 at x equals 4? Well, we got to do a little bit of math to find that out. So if I want to know what my 0 is at x equals 4, or if that's true, I'm just going to plug in 4 and determine if my equation equals 0. So I got to substitute 4 for x, okay? So in here I got to do 4 minus 4 squared minus 1. So 4 minus 4 is obviously 0. 0 squared is 0. 0 minus 1 equals a negative 1. So do I have a 0 at where x equals 4? No, I have a negative 1 where x equals 4. So that's not going to be an answer either. Okay? So I canceled A, or I crossed out A, crossed out B. Does it have a minimum at x equals negative 1? Ooh. Well, our minimum value is where x equals 4 and y equals negative 1, right? So that's not going to be it. Does it have a 0 at 3? Well, let's go back and let's try this again. We'll use green. At 3, well, 3 minus 4 squared minus 1. 3 minus 4 is a negative 1. Negative 1 squared is a positive 1. So all that equals 1. So 1 minus 1 equals 0. I do have a 0 where x equals 3. So there's an answer. Let's look at f. I don't have a maximum value, so I can cancel that out. Right? It goes to infinity upwards. And then e says the minimum value of f of x is -1. Yes, the minimum value of f of x, which is also known as y, is -1. So my answer is going to be D and E. Okay, let's move to the next problem. 23. Which of the following functions is equivalent? It's a little bit more time consuming because we have to actually go through and find two possible answers, right? This one you should identify for A, that's not going to work. X minus 6 squared is going to be x squared minus 12x plus 36. And if I subtract 28, well, it doesn't even matter because it's not, my b value is not a -6x, right? It's a -12x. So I can disregard A. Let's look at B. If I were to multiply B, I get x squared minus 6x plus 8, right? There you go. There's one match. It's exactly the same as that. Let's look at my next one. I have x minus 3 quantity squared, so that's x squared minus 6x plus 9, and then I have that minus 9 at the end. Well, 9 minus 9 will cancel out and give me 0. I don't need a 0, I need an 8. So C is not it. X minus 3 times x minus 3 is just x minus 3 quantity squared, which is x squared minus 6x plus 9. That's not it, because I need a plus 8. So it must be E. Let's just double check. X minus 3 quantity squared is x squared minus 6x plus 9. And then I have that minus 1, and 9 minus 1 is 8. Yay, got that. So your answers are B and E. Alright, number 24 says Troy signed up for a new cell phone plan which charges him a fee of $40 a month, plus 5 cents for each text message that he sends. He wants to spend at most, keywords, at most $70. So as soon as you think that you see those words right there, at most, you don't want to spend any more than $70. So your inequality is going to be less than or equal to $70, right? And so what's your answer going to be? Well, it's not greater than or equal to, right? It's not greater than. It's not less than, it's less than or equal to. So you spend $40 for the month and then 5 cents for every text message. Your answer is C. Alright, we got our last problem here. Number 25. Got a land developer, excuse me, looking at the drawing above of her property, knew that altogether she had 300 square blocks, but she wanted to know how many blocks were in X. So this is saying the area is 300. How many blocks fits in represents that X. And so she got this formula. And she got this formula because she found the area of this rectangle, which is X times X, is represented there. And then she got the area of this rectangle, which is X times 5, which is represented there. And together it equals 300. Okay? So, what is a reasonable value for X? So if you're looking at this, you're thinking, well, maybe I should try to put that in standard form. And then I'll either factor or use the quadratic formula or whatever I need to do. Right? So to bring that 300 to the other side, I'm going to subtract 300, and then it equals 0. And this is actually factorable. Okay? What times another number equals negative 300, but adds to 5? I believe it's going to be 20 and negative 15, right? Those two numbers will multiply and give me a negative 300, but when I add them, it's going to give me a positive 5. So, if you still need to use the generic rectangular factor, go for it. But because my a value, and here this trinomial is a 1, I don't need to do that. It's real simple. I just take my positive 20 value, and I put it there, plus 20. This minus 15 goes right there. And using the zero product property, I know x is going to equal negative 20, and x is going to equal positive 15. So this question says, what is a reasonable value for x? It doesn't say what does x equal, right? So x equals negative 20 and positive 15. But which one of those two is actually a reasonable answer if we're looking for the distance, or measurement of distance is what we're looking for, right? Well, let's say it's like a fence or something that she has to build. I don't know what it is. You can't build something that has or they're blocks, excuse me. You can't have something that's a negative amount of blocks. So automatically your answer of negative 20 is not reasonable. So the only logical answer here would be 15 blocks, right? It's either, the answer is either negative 20 or positive 15, because that's what we got when we solved for x. But it's not reasonable to have a negative amount of blocks. Alright guys, that's it for this review. Remember to take your test Thursday or Friday. Stop by our Google Meets, ask questions, set up a Calendly, or shoot me an email. I am happy to help. Hope you guys are doing well. I'll see you soon.